Hello everyone. This session we go to the algebra part of the trigonometry as calculating the summation of the two angle of the sine cosine and have another identity formula. Okay, so let's directly look at this one. So here we have sine and cosine. I provide both of the summation and the difference. So let's first start from the sine. So the sine summation, sine a plus b, a plus b, a are angle a, b are angle b. The two angle together is equal to sine a cosine b plus cosine a sine b. If the difference, the change is the minus in between. Okay, so let's see cosine. Cosine, the difference is s plus and middle, but both are cosine and plus sine. While the summation of the cosine two angle is the minus in between. I will not waste my time to prove that because this will be spent long time for that. Okay, but just make example. If you know the cosine of the difference, definitely you know the sine already, right? Right? Because cosine, sine and cosine have similar, right? Sine and cosine. We know the cosine, we know sine, right? We learned that last session already. And we know the summation, definitely we know the division. Oh no, sorry, we know the difference, right? Right? Okay, this can be treated as a negative b plus negative b angle, right? Another one we have to learn is a cofunction identity is based on the 2 pi over 2. So you can see here cosine pi over 2 minus b equals to sine b. Sine pi over, you see that cosine and sine, right? And then they are equal another side of sine and cosine is based on pi over 2 minus. Then tangent and tangent and cotangent are similar. This one is quite easy to approve. Just give example for the first one. First one, you observe you can treat as a minus, right? Like a cosine 2 pi minus cosine b. You can write in as what? You can write in as cosine pi over 2 times cosine what b. Then since it's minus, should be plus, right? Sine pi over 2 and sine b. Oh, so it's quite easy. Cosine pi over 2 is what? 0. So this is 0. And then plus sine of pi over 2 is 1. So this definitely is sine b. So, right? So, same, right? So, it's very easy to prove. Okay, so I will just give one more example to end this session. But after the class, you can try a lot of exercises. This is very interesting if you like algebra. Okay. And look at here. The questions ask you to calculate cosine 75. What's the knowledge you need to have is you have to remember or at least know what we teach before. Some special angle you have to be familiar. What's the special angle? Is the 30 degree and the 45 degree. Okay, here I draw them. So for this one cosine, we can write in as cosine 30 plus 45. Right, can be like this way, right? So since it's plus, so it's become a minus in between. So cosine 30, then cosine 45, then minus what? Sine 30, sine 45. What is cosine 30? Cosine 30, we remember here, for the 30 degree, the speciality is x is 1/2 of the r, right? So r is 1, then x is what? X, sorry, y is 1/2. Y is 1/2. Okay, Y is 1/2. Okay, so here, and the y is 1/2, then x is equal to what? So I need to have a little change. Have a little change. Yeah. Okay, so x will equals to, it's very clear. Let me make it green. S equals to square root of 3 over 2, right? Why? Because it's because x square plus y square equals to r square. R here is 1, right? And the y here is 1/4. So square plus equals to, so x square equals to what? 3 over 4. Right? So then square root of both sides. So x equals to what? Square root of 2, right? So cosine is what? Cosine is x over r, right? R is 1, so cosine here is square root of 3 over 2. How about the cosine 45? For 45 is also special. 45, both sides are 1, while r is square root of 2. Okay, so cosine 5 is equals to what? 1 over square root of 2. Then minus sine 30 is 1/2. And then sine 45, same, 1 over square root of 2. So the final answer is square root of 3 minus 1. Right? This is the final answer. Don't say this is not the final answer. Yeah, this is already final answer. Okay? This is already final answer. Because any kind of, if you want to get just a exact number, then they will be similar, not exactly the same. Because for square root of 2 and the square root of 3, they will be infinite decimal. Okay, so this is the final answer. Okay, so for this session, we introduce the different law for the summation and the difference of the sines and the cosine of the angle A and B. And also we introduce the cofunction identity, and which is very, very easy to prove. So please do more exercises and the class, so you will be more familiar how to use this function. As I just give a implementation such as sine A plus b, if we can treat as a equals to b, right? Equals to b, then it will be looks like 2b, right? Sines 2b, right? Sines 2b equals to what? Sines b cosine b, right? Sines b cosine b and the plus cosine b sine b. So is equals to what? 2 sine b cosine b. Am I right? This is a kind of application we can. If it is sines 2a, so equals 2 sine a, yes, cosine a, right? So it can be like this way. So okay, so there's a lot of things that you can do and the side of this class. So thank you very much to join this session. Okay, thank you. Bye bye.